Hi, my name is Charles Genovese, and I am doing a reassessment video on Chapter 14 on the interaction between a neutral atom and a point charge. I have drawn a neutral atom and a point charge separated by a distance r. The electric field of the point charge polarizes this neutral atom, creating an induced dipole. This induced dipole has an electric field that exerts a force on the point charge, and this induced dipole's electric field can be represented by this function. The function is 1 over 4 pi epsilon naught times 2p over r cubed. Now this is derived from the function for an electric field of a dipole parallel to a point charge, which is 1 over 4 pi epsilon naught times 2qs over r cubed, where the condition is that r is much greater than s. Qs represents the magnitude of this electric dipole moment, p. However, the amount of polarization of the induced dipole is directly proportional to the magnitude of the applied field that created the dipole, and this can be written as P equals alpha E. So, plugging that in, alpha is the polarizability constant of a particular material, and E is the field from the point charge. Because this is just the fields from a point charge, we know the point charge equation and can just plug that in directly, and giving us this value. Combine a few like terms, and then we'll end up with this. And this is the electric field of the induced dipole. Now let's say you want to find the force on the point charge due to the electric field of the dipole. Well, we can just use Coulomb's law, which is the relationship between force and electric fields, which is this. We just solved for E2, so we can just plug that in directly, giving us this. Once again, combine a few like terms, rearrange a few things, and you get this. But what if we want to find the force on the atom by the point charge? Well, we know from Newton's third law that if these particles aren't accelerating and they're the only two things interacting with each other, then the forces are equal and opposite. Equal and opposite, giving us this negative value, which is the same as this equation earlier.